So we're on page 39. It's going to have some cross-section warm-ups, and it's going to have some other materials that will all be a part of the geometry unit. Oops, I don't know why I put a 4 there. Alright, let's go ahead and start going over this. For problem number 1, what is the parallel cross-section of a trapezoidal prism? Parallel cross-section of a trapezoidal prism. What'd you guys get? Say it loud. Trapezoid. Okay, so it's going to be a trapezoid because of the fact that it does say that it is a parallel cross-section. Parallel cross-section. Whenever it is parallel, parallel cross-sections are going to mirror the base. They're going to be identical to the base. So if we want to write that down, a parallel cross-section mirrors the base shape. And in this case, our base shape is based off of what the name is. The name is a trapezoidal prism. So trapezoidal prism means that the base is going to be a trapezoid. Right? That's our base right here. So a trapezoid is what we're going to see. When in doubt, you could also just draw it. If you draw a trapezoid, and then try to mirror that, to draw a congruent one, this is what the trapezoidal prism looks like. And when it's a parallel cross-section, that means you're kind of having a cross-section that's going to go right through here. So you're going to wind up getting your base shape again. Okay, parallel cross-sections means they do not touch the base at all, so the base stays 100% intact. So you would just see the same shape. Okay, let's take a look at problem number 2. What is the only cross-section a sphere can ever yield? Go ahead, everybody should be saying it. Circle. Only cross-section that a sphere can ever yield is a circle. It does not matter how you cut it. You will always get a circle. No matter how you cut the shape, a circle is the only one that you're going to be able to get from a sphere. Okay, all prisms have what shape for their perpendicular cross-sections? Rectangles. Very good. So for perpendicular cross-sections of prisms, you're only going to be able to get a rectangle. No matter what prism you have, whether it is a cylinder, which is a kind of prism, it's not called a prism, but it's similar to it. Okay, prisms mean that they have two congruent bases connected together by rectangles. Okay, so a cylinder is somewhat similar to a prism. Or if you have a triangular prism, okay, or if you have a rectangular prism, this is going to be a really bad connection here, but it's a similar idea. Okay, when you cut this perpendicular to the base, that means you're slicing through the base. And all we're going to be able to see when we pull this apart, when we actually snap it open, is going to be rectangles. So let's just take the cylinder. If we snap the cylinder open, all we're going to see are these rectangles right here. Okay. For number 4, all pyramids have what shape for their perpendicular cross sections? What are they, guys? Triangles. Okay, if it is a pyramid and it is a perpendicular cross section, you're going to get nothing but triangles. Okay, again, a cone is somewhat similar to what a pyramid would be. Okay, you also have a rectangular pyramid. You can have a triangular pyramid. Okay, all of these, when you cut them perpendicular to your base, you're slicing straight through the top down to the base shape and pulling it apart, you're going to see nothing but triangles. Okay, for problem number 5, we're going back to our ability to solve information, to solve. So using this, I went ahead and put it in order from a way that you can solve. So if we start with A, we can solve this because A creates what relationship here? What relationship is created with A and 60? Say it louder. Say it. If you're going to say it with confidence. What is it? Complementary. Thank you. Complementary angles right here. So A plus 60 is going to be equal to 90 degrees because these are complementary angles. Then all we have to do is subtract 60 from both sides. and we'll get that A is equal to 30 degrees. So A is 30. And if I know that A is 30 and I know that this angle is 90, then I can use my triangular sum theorem to solve for B. Triangular sum theorem states that A plus this 90 plus this B is going to equal how many degrees? 180. So I can do B plus 30 plus 90 should be equal to 180 degrees. Now 30 plus the 90 is going to actually come out to 120, so I get B plus 120 is equal to 180 degrees. When I subtract 120 from both sides, I'm going to be able to get that B is equal to 60 degrees, which also makes sense because these are parallel lines, and this can technically be construed as a transversal, making those alternate interior angles. You could have that as one. Okay, the next concept, I went ahead and gone to the order for C. I can solve for C because what kind of relationship exists here? Supplementary. So we have supplementary angles, meaning that C plus 125 is going to be equal to 180 degrees. If we subtract that 125 from both sides, we're going to get that C is equal to 55 degrees. So if I know that this is 55 degrees and this is 60, I can solve for D because, again, I can use that triangular sum theorem. So 55 plus the 60 plus D is equal to 180. 55 plus 60 is going to give me 115. So I get 115 plus D is equal to 180. I would then just subtract 115 from both sides, and I would get that D is equal to 65 degrees. Okay? Using all of our little information that we know, we can solve for every single one of these. Now, there is also a really neat trick. Here's the really neat trick. 125 is considered to be an exterior angle. An exterior angle to the triangle. All exterior angles on triangles are equal to the sum of the two opposite interior angles. Here's 125. 65 plus 60 is equal to 125. That's just a neat little trick to know. All exterior angles on a triangle are equal to the sum of the two opposite interior angles. Opposite meaning not the supplementary pair. So obviously that can't be considered part of it. But 60 plus 65 is going to equal 125. We'll do some more practice like this later, but I'm just introducing that concept to you. Don't be surprised if I throw this in a warm-up tomorrow as well. Okay? All right, let's go ahead and move on. We're going to get into page 40, talking about circles. It is not a perfect circle. But it's quite nice of you to think that it was. Alright, so here we're talking about circles. And it's important to understand the parts of a circle. The parts of the circle will help you to be able to solve for different aspects of your circles. Okay? So the very first part that we're going to talk about is this short end. So notice we have a circle and we have a center point. Now the center point means that no matter where you go from the center to the circle, it's all going to be the same measurement. So that same measurement from center to anywhere on your circle is called the radius. Now, again, like I said, the radius, that is the distance from any point on the circle to the center. Any point on the circle to the center, that's called the radius. Then you've got this measurement right here, this longer measurement, that spans from any point on the circle straight to the center and straight across to the opposite side until you hit the circle again. That is called the diameter. So I'm going to turn this real quick. Some people accidentally pronounce it sometimes or mispronounce it as diameter. It's diameter. Diameter, not diameter. So the diameter is the distance from one point on the circle and then it passes through the center. So it has to pass through the center. If it doesn't pass through the center, then it's not considered a diameter. That would be considered a chord. So it passes through the center, and then it extends to the other side. It extends to that opposite side, or that opposite point. Now, something that's really important for you to notice, if I start at any point and go to the center, that's first called the radius. So we technically have a radii located here and here. We have multiple radii that extend all throughout the circle. Because again, it's no matter where I start on the circle, if I go to the center, that's considered to be a radius. So notice how many radii will make up the diameter. Say it louder. 2. Okay, 2 radii, right? We have a single radius right here from this part of the circle to the center, and another radii here, or radius here, from the center to this part. So the radius is the same thing as taking the diameter and dividing it by 2. And the diameter is the same thing as taking the radius and multiplying it by 2. Double the radius will give you the diameter. Half the diameter will give you the radius. Okay, then you have the distance that surrounds the circle. Now, most of the time when you guys look at distance around the shape, you call that perimeter. Circle is the only one that has a unique name for that. We don't call it the perimeter, we call it the circumference. So I'll put in parentheses, aka perimeter. And that's just the distance around the circle. The distance around the circle is called the circumference. Now we also have one more unique little thing. Pi. And pi is equivalent to 3.14. It's equivalent to 3.14. Okay, let's go ahead and get into our formulas, what we need to know. And formulas will be given to you for this unit test. They'll also be given to you when it comes to your final exam. It will be on the computer just like it was with the interim. So you will have to open up the formula sheets. Okay, they won't be handed to you as an actual sheet of paper. It will be located on the computer itself. Okay, so let's talk about the circumference formula. Okay, with the circumference formula, we call that C, big C. Circumference formula is taking the diameter, D, and multiplying it by pi. You take the diameter, D, and you multiply it by pi. Now, the reverse aspect of that. So if you were to do the inverse, in order to solve for D, diameter, diameter is the same thing as circumference divided by pi. Right? Diameter times pi gives you circumference. If I divide circumference by pi, I'm left with diameter by itself. It's just basic equations. Pi is a number. So to do the inverse operation of multiplication, you would divide. So circumference divided by that pi value will equal your diameter. Area. Area is equal to the radius squared times pi. Now, please keep in mind, this is something that's important for you to remember. R squared means R times R, not R times 2. That's the biggest mistake that I see every single year. People think R squared means that they're going to do R times 2. So they're like, oh, 4 squared is 8. No, 4 squared is 16. You're doing 4 times 4, not 4 times 2. So please keep that in mind. If we're talking about the reverse of it, the reverse concept. So if you're given radius, you can solve for area, but the same thing can happen. If you're given the area, you can solve for the radius. The radius can be found by taking your area and dividing it by pi, and then taking what's called the square root. So you would do area divided by pi and then take the square root of that value. Okay, so let's do a little bit of practice. I want you to find the circumference and the area. We're going to find the circumference and the area for that problem. Now, in a situation like this, the first thing that you want to do is identify what you know and then what you can learn from the information that you know. So right now, what information do we know about this circle? Alonzo?
The radius is 5 inches.
We know that the radius is 5 inches. Very good. So we know that this measurement that's given to us is the radius. So we know that the radius is going to be equal to 5 inches. So now I just start piecing things together. Because I know the radius is 5 inches, can I solve for the diameter? How do I find the diameter, guys, if I know the radius? What do I have to do? Multiply it by 2. Since I know that the diameter, since I know that the radius is 5 inches, all I have to do is take 5, multiply it by 2, and that's going to give me the diameter. The diameter is 10 inches. The diameter is double the radius. Now, I know the radius, I know the diameter. I can take those pieces of information and plug them into my formulas. Circumference just needs diameter. Area needs the radius. So let's start with circumference first. Circumference formula is diameter, d, multiplied by pi, which is 3.14. So we're going to take 10 and multiply it by 3.14. And that's going to give us our circumference. So our circumference is going to come out to 31.4 inches. Please do not forget to put your unit of measure. In geometry, a unit needs to be provided. Now before I forget, up at the top where it says area, put a little squared value above it, a 2. Circumference has units in inches, meters, feet, yards. Area has those units squared. So when you provide your answer, it's inches squared, feet squared, meters squared, yards squared. Okay? Doesn't mean that you're squaring the number. It means that the unit itself has a squared value. So now let's talk about area. So again, the area formula is the radius squared times pi. So we're going to substitute r, the radius, with a 5. So we're going to put 5 squared times 3.14. What's 5 squared? 25. 5 times 5 is 25. So then we're going to do 25 times 3.14, and that will give us our area. So the area in this case is going to come out to 78.5, and again, it's inches squared. You have to put the squared measurement. You have to put that squared measurement on the inches. Go ahead and take a second to get that copy down, and then I'm going to flip to the next page, and you're going to try one on your own. Huh? You good? Okay, let's go ahead and go on to the next page. Page 41. I want you to try this one on your own. Try that one on your own. You're going to find the area and the circumference. Okay, so for problem number 2, what information has been given to us? What is this called? The diameter. Okay, so we know that the diameter's measurement is 16 feet. So I know the diameter is 16 feet. Because I know the diameter, I can easily identify the radius. How do I change the diameter to the radius, guys? Divide it by 2. Good, so we're going to take 16, we're going to divide it by 2, and that's going to give us a radius of 8 feet. Now that I know both the radius and the diameter, I can solve for circumference and area. Again, circumference, we're going to take the diameter and we're going to multiply it by pi. The diameter in this case is 16. Pi is 3.14. So we're going to do 16 times 3.14. That's all you have to do. which comes out to 50.24, and that is feet. 50.24 feet. Okay, now we're going to do the same thing for area. Our area formula. Area is equal to radius squared times pi. Okay, so instead of r, we're going to put 8. So we're going to do 8 squared. And instead of pi, we're going to put 3.14. 8 squared. 8 squared comes out to 64, right? 8 times 8 is 64. So we're going to do 64 times 3.14. And we get that the area is 200.96, and that's feet squared. Feet squared. Okay? Now, like I said, sometimes it might have you do things in reverse. So let's say that I am telling you the circumference. The circumference is going to be equal to 32.656 meters. 32.656 meters. I want to know, what is the diameter? So C is equal to 32.656, and I want to solve for the diameter. Remember that the diameter can be found by taking that circumference and dividing it by pi. So we can actually take 32.656 and we can divide it by 3.14. So 32.656 divided by 3.14 is going to come out to 10.4, and that is meters. 10.4 meters. You're just utilizing those formulas that I gave you on the first page. Number 4, try this one on your own. Area is equal to 84.9056. I want to know what is the radius. What is the radius? So you're going to work backwards through your formula that I gave you. Alright, so let's go ahead and take a look. I said before that you can find the radius by taking the area, dividing it by 3.14, and then taking the square root of that value. So what we're going to do is take 84.9056 and we're going to divide it by 3.14. So when we do that, 84.9056 divided by 3.14 comes out to 27.04. Then you have to take the square root. Now, the square root symbol, for those of you who don't know where it is on your calculator. So if I take 27.04 and I want to take the square root of it, I first need to clear that information, and your square root button is right above the x squared button in green. So if it's above the x squared button in green, what do I have to press to get to that green? You have to hit the second button. Good. So we're going to hit second, and then we're going to hit that x squared button. And notice your square root symbol is going to pop up now. I can then type 27.04 and hit enter, and I get 5.2. So you have to do your division first. You have to divide first, then you can take the square root and you get your answer. Okay, and this is units squared. Since I didn't give a unit of measure, I would just put units squared. Okay, the last little thing I want to show you for today is just if I happen to give you a semicircle. A semicircle is just half of a circle. A semicircle is just half of a circle. So if I tell you that the semicircle has a radius of 3 yards, then in order to find the area for a semicircle, you're still going to do the pi r squared, or r squared times pi. But then, because a semicircle is half of a circle, what do you think you're going to do then? Aaliyah? Divide it by 2. You're just going to take the area formula and divide it by 2 for a semicircle. Okay? So this is going to come out to 3 squared times 3.14, and then we're going to divide that by 2. Now 3 squared is 9. So we're going to do 9 times 3.14, and then divide that by 2. So our area will wind up coming out to 14.13 yards squared. Okay, so you're going to have a worksheet for tonight. It comes out of your all's workbook, so I went ahead and made copies of it. It is due tomorrow. It's due tomorrow. We're going to go over it at the beginning of class. So if you don't finish it, then whatever you don't finish gets marked wrong. Please keep that in mind.